The next decade will be crucial for space travel. We've finally set foot on the moon again with the first crewed Artemis mission scheduled for 2025, and we'll now take our first steps towards establishing a permanent human presence there. And we'll also start our journey to Mars with the first crewed mission to the Red Planet slated for 2033. Missions will push the boundaries of what it means to be a human in space, requiring astronauts to spend more time away from Earth than ever before. But that presents a serious challenge. Our bodies evolved under the influence of Earth's gravity, and so prolonged exposure to microgravity conditions will likely have some very negative consequences for the human body. So how do we protect our astronauts on these long journeys? One team of scientists believes they may have just created a big breakthrough. They've designed a rotating space station that could simulate gravity using centrifugal force. And it might just be the key to making humanity a true spacefaring civilization. Gravity has an impact on every aspect of life on Earth. It affects the way our cells work down to our DNA most obviously, though it shapes our bodies. Over billions of years, life on Earth has evolved to thrive under 1 gram of gravitational force. This force compresses our bodies, particularly our bones and muscles, which makes them stronger. It also helps our cardiovascular system function by forcing our heart to pump blood against gravity. Without gravity, our bodies would simply float away into outer space. But as well adapted to 1 gram as we are, humans were never meant to go to space. And so far, only a small number of people have ever experienced zero-G or microgravity conditions, where the force of gravity is incredibly low compared to what we experience here on Earth. On the ISS, for example, astronauts experience around 90% of 1 gram, but it still has a noticeable effect on their bodies. For example, our bones don't need to be as dense and strong when there's no gravity pulling them down. And so over time, the lack of gravity causes bone density to decrease, increasing the risk of fractures. In zero-G, bone loss happens much faster. After just 2 weeks in space, astronauts lose up to 1% of their bone mass per week. And after 3 months, they can lose up to 11%. In microgravity, our cardiovascular systems also suffer. With no gravity to pull against, our blood no longer pools in our legs. Instead, it tends to gather around our chest, resulting in higher blood pressure. As a result, our hearts have to work harder to pump blood throughout our bodies. That's why astronauts on the ISS are at a higher risk of cardiovascular disease. Microgravity also messes with our sense of balance. We're used to relying on our inner ear, our eyes, and our feet on the ground to keep us upright. But without gravity, all those systems get thrown out the window. Just ask the astronauts who've previously tried to walk on Earth after spending extended periods in space. It often takes them a while to get their bearings. In extreme cases, it can even cause permanent damage. For example, after spending 437 days in space, the Russian cosmonaut Valery Polyakov experienced such severe disorientation when he returned to Earth that he was unable to walk unaided for several months. This is why astronauts on the ISS have to exercise for 2 to 3 hours every day, performing a range of movements to simulate walking, running, and jumping. But this isn't a perfect solution. Not only is it incredibly time-consuming, it also doesn't completely prevent the negative effects of microgravity. So scientists are looking for other ways to help astronauts cope with space travel, which brings us back to gravity. If we can't remove astronauts from the effects of gravity, then maybe we should try and add some artificial gravity to counteract the negative effects of microgravity. And one way to achieve that is through centrifugal force. Centrifugal force is essentially an inertial force that pulls objects away from the center of rotation. It's what makes roller coasters feel like they re-pushing you out of the loop, or what makes it feel like you being pulled sideways when you on a roundabout. It's also the force that scientists think they can use to mimic gravity in space. A 2021 study published in the Journal of Space Policy suggested that centrifugal force could be used to simulate Earth-like gravity in deep space. The idea was to design a space station with a rotating ring. The ring would spin at around 5 rotations per minute, which would create a centrifugal force equal to 1 gram, the same as Earth. Anything placed inside the ring would therefore feel like they were under the influence of Earth's gravity. However, this wouldn't be a complete solution since astronauts would only experience artificial gravity while inside the ring. So another team of scientists proposed an alternative design, a space station that looks like a giant donut. The ring itself would be hollow and serve as living quarters for the crew, while the middle section would contain all the spacecraft's technology. And because it would be made entirely of spinning cylinders, the whole thing would have to rotate at around 0.175 rotations per second to generate enough centrifugal force to create a 1G environment. Sounds pretty easy, right? Well, a 2023 paper published in the Journal of Theoretical and Applied Mechanics took this idea a step further. It proposes creating an artificial gravity environment in a space station with a radius of 35 meters by rotating it at half a rotation per second. To put that in perspective, the authors said that if the crew were to experience just 1/10 of this gravity for 6 months, it would be equivalent to exercising for 2 hours every day on the ISS. Of course, it's important to remember that just because something is rotating doesn't automatically mean it's a comfortable place to live. If you've ever been on a roundabout that spins too fast, you'll know exactly what I mean. So it's important that the artificial gravity is adjustable. The team behind a new study has designed their space station to use magnetic bearings to make the rotation smooth and free from any jolts. There are many benefits to using centrifugal force to create artificial gravity. For one, it would allow astronauts to move around more easily, reducing the risk of falls and fractures. It would also improve their cardiovascular health by helping to maintain normal blood pressure and reduce the risk of heart disease. Additionally, it could help astronauts maintain their muscle mass and strength, reducing the need for lengthy exercise regimes. And it's not just beneficial for the body, it could benefit the mind as well. A 2022 study found that simulated gravity helped rats adapt better to psychological stress, suggesting that it could help astronauts cope with the isolation and confinement of long-duration space travel. But perhaps most importantly, it could make long-duration space travel possible in the first place. As things stand, the longest single mission in space lasted for 437 days between April 1994 and March 1995. It was completed by the Russian cosmonaut Valery Polyakov while he was aboard the Russian space station Mir. It's unlikely that any human could survive in space for years without experiencing negative physical or psychological effects. But if we could find a way to alleviate these issues, that would open up the possibility of longer space missions. It would enable us to establish a permanent human presence on the moon and lay the groundwork for sending astronauts to Mars. If you thought this video was cool, you'd probably love our video about NASA's plans for the moon. Check it out here.